All right, now that you're familiar with parametric equations, let's look at some restrictions and some idea of what we're going to do when we try to relate parametric equations and rectangular ones. So one of the things that we like to do and we like to be able to do is to convert the parametric equations to rectangular equations, right? For a variety of different reasons, sometimes we like to do that. So let's say that you're given a parametric equation. And remember, a parametric equation is given in sets of x and y with respect to t. So let's say that your parametric equation here is x equals t squared minus 5 and y equals 4t. To convert this from a parametric to a rectangular equation, what you want to do is solve for t in terms of x, okay? And the reason you want to do that is you want to solve for t because what you want to end up with in a rectangular equation is a y equals, right? That's a y equals equation. And so there's no use in solving for t in terms of y because you can't replace it back for itself, right? You can't substitute it in back for itself. So let's solve for t in terms of x. So if x equals t squared minus 5, I'm going to add 5 to both sides, and then I'm going to take the square root of both sides to solve for t. So t is just the square root of x plus 5. Okay? And so if t is just the square root of x plus 5, what we're going to do now is we're going to take this value of x plus 5, we're going to look at this parametric equation of y equals 4t, and we're going to substitute it in. So I'm going to take this value here, and I'm going to substitute it in for t. And so y is equal to 4 times the square root of x plus 5. Now, there will be different times that we'll do different varieties of this, but the basic idea is the same. You're going to solve for t in terms of x and then substitute into y. Now, what about domain restrictions? What if you're given a parametric equation that has rules that you have to follow? Well, you have to follow those rules. Okay, so if you have to follow those rules, then remember we cannot violate the rules of math to do this. So let's look at an example for that. Let's suppose you're given the parametric equation x equals 1 over the square root of t and y equals t plus 1 over t. All right. Again, we're going to use the same process. We're going to solve for t in terms of x. Okay, so to do that, I'm going to multiply both sides by the square root of t to get that t out of the denominator. So then I end up with this, right? I'm going to end up with square root of t times x equals 1, right? I'm going to divide both sides by x, so the square root of t is equal to 1 over x, and then I'm going to square both sides, so t equals 1 over x squared. Okay, and that works out great. We're going to substitute in, like we said before, we're going to go to this parametric equation here, and we're going to substitute in 1 over x squared every single time we see the letter t in this original equation. So we're going to take this, right, and we're going to put it everywhere we see t in there. So let's do that over here because I'm running out of space down there. Y equals 1 over x squared plus 1 over x squared. Remember, I'm going to multiply both sides by the reciprocal, or I'm going to multiply by the reciprocal because I'm dividing by 1 over x squared. So then what I end up with is this. And then I'm going to distribute my x squared, so I'd end up with 1 plus x squared. Now, normally we would be done, except this. There is a domain restriction here, right? Not only is it a square root, but it's also in the denominator. So we have some rules for this, right? We have some rules for what t can't be. We know that t can't be 0. Right, because you can't divide by 0. But not only that, we don't really want to deal with the imaginary numbers. T can't be, if we're talking about real numbers here, then t can't be negative either. So t actually has to be greater than 0. So when we're talking about this domain restriction, that does carry over into our final rectangular equation over here. So when you write this equation, you're not done until you say that x must also be greater than 0. All right, we have to make sure that we carry over those restrictions. Now, let's talk about how to write parametric equations from graphs. Okay, I wish I could give you a great graph. I'm a little iffy drawing on this thing, so let's suppose I give you the equation for a graph. All right, let's say that I give you a rectangular equation. So I know that the graph looks like this. Okay, and we just studied conic sections, so you know that that's a parabola and it opens up with its vertex at 0, -4. Okay, we know that it's a parabola and it opens up and it's a vertex is at 0, -4. Now, the way that we do this is we actually have to know something about the parameters. So let's look at a couple of different ones. Let's look at one where the parameter t equals x. The first thing that I'm going to do here is if I ask you to write a parametric equation, right? So what I'm asking you to do here is I'm asking you to write a parametric equation. And that's given this rectangular form, okay? And so to do that, I have to know something about that parameter. So I'm telling you that t is equal to x. Okay, so now what I want to do is I want to solve for x in terms of t. So we're going to go just the opposite of what we did before. And to do that, then I'm going to just, in this case, flip them around, right? And x equals t, because that's not that complicated. And then now I'm going to substitute in everywhere I see t, the letter x, I'm going to substitute that in my original equation. And so this particular parametric equation, given that t equals x, is actually y equals t squared minus 4. Now, what if you're given a different parameter? Well, let's look at that. Let's suppose that you're given a different parameter, and you're given the parameter 4x plus 1. And what I want you to look at is we're going to do the same thing. Let's solve for x in terms of t. So I'm going to do t minus 1, right? T minus 1 is equal to 4x, and then divide everything by 4. So x is equal to t minus 1 over 4. Now I'm going to do the same thing. Everywhere I see the letter x, I'm going to substitute in this t minus 4 over 1. So now we're looking at y. We're looking at y equals t minus 1 over 4 squared, okay, minus 4. So let's go ahead and square that out, right? T squared minus 2t plus 1 over 16 minus, and I'm going to go ahead and convert that 4 because I'm looking at that 16 and I know I'm going to need a common denominator. So let's go 64 over 16 here. I'm going to go ahead and split this up because I can simplify it if I do that. So I'm going to look at t squared over 16 minus t over 8, right, because I reduced out the 2, plus 1 over 16 minus 64 over 16. That becomes a negative 63. So I end up with t squared over 16 minus t over 8 minus 63 over 16. And this is my new parametric equation given the rectangular one. So what I want you to do now is I want you to graph both of these parametric equations. Okay, graph this one and graph this one. All right, and I want you to see if you can figure out what the difference is between those two equations and why it would be important to know something about that parameter before we write the parametric equation for it, right? Why can't they all be the same? So go ahead and graph them, and then we'll talk about that more in class.